Welcome back. In this training byte, we will create a new power-aware parallel bus system topology. This training byte, as well as the others that will follow, will assume that the previous training bytes have been viewed and the related lab material up to this point has been completed. This training byte will use S parameters to now simulate the effects of packages as well as the topology of the layout when routed on a PCB. As always, for more detailed instructions, please go to support.cadence.com, where you can access the lab and training course that will guide you through the Security Topology Workbench tool with System SI for parallel bus and serial link analysis. To start, we will remove the trace and tuning blocks that we had created in the previous training bytes. Click on a block and press Delete on the keyboard to delete a block. Add a SPICE block between the controller and the memory. Rename this block to PCB. We will be adding an S parameter model file generated by PowerSI. Navigate to the viper_trng_PCB_DDR4_decaps_2mums_5 GHz.ckt file in the module 3 folder and replace the default SPICE file attached to the PCB block. To further reinforce the skills learned in the previous training bytes for connecting blocks, we will modify the pinout of the SPICE block. Right-click on the PCB block and select Setup Default Pin Locations. Click on the Odd option, and then the Sequential option. Open the 2_left pins by clicking on the triangle and note that U26 and U28 are the memory components. Edit the name to be memory and change the location to right. Edit the name for the 2_right pins to be controller and the location to left. We will now add the effects of the controller package into the topology. Add a SPICE block to the topology between the controller and the PCB block. Navigate to the DDR4_PKG_SPICE_pi.ckt file in the module 3 folder to attach this file into the SPICE block. Rename this block to controller package. Similarly, we will add the package effects to the memory components, so add a SPICE block between the PCB block and the memory block. Add the DDR4_PKG_SPICE_pi.ckt file to the memory package block. Rename this block to memory package. We will add a VRM block to account for the power distribution network's effect on the DDR4 topology. Add the VRM block under the PCB block, and edit the block so that it has a typical value of 1.2 volts, a minimum of 0.64 volts, and a maximum of 1.56 volts. Finally, add another pair of memory and memory package blocks. You can do this by either adding blocks manually as we have done earlier, or by using the Ctrl+C and Ctrl+V hotkeys. Ensure that the blocks have the same package and IBIS files as the other two original blocks. We will connect these blocks as we have done in the previous training bytes. Connect the DQ0 to DQ15 signal nets of the controller block to the DDR_data0 to DDR_data15 signal nets of the controller package block. Connect the LDQS net of the controller block to the DDR_DM_P0 net in the controller package block. Connect the LDQS hash signal to the DDR_DM_M0 net. Connect the UDQS and UDQS hash nets to the DDR_DM_P1 and M1 nets respectively. Connect VSSQ to VSS and VDDQ to VO_phase. Repeat this process with the rest of the blocks. This concludes the setup of our power-aware topology. Please refer to the additional training bytes in this channel, as well as the lab manual, to continue learning about the Security Topology Workbench tool with System SI.